Right now, you're experiencing the present. The past is behind you. Memories, history, already happened, gone. The future is ahead. Uncertain, not yet real, hasn't happened. But according to physics, you're wrong. The block universe theory says past, present, and future all exist simultaneously. Time doesn't flow. It's all there, frozen in a four-dimensional structure. Your life, from the moment you were born to the moment you die, exists completely, right now. You just experience it one moment at a time. Why? Because of quantum entanglement. Recent experiments from 2024 and 2025 suggest time itself emerges from quantum correlations. Your sense of now is created by entanglement between you and the rest of the universe. Time isn't fundamental, it's derived, an illusion. This is the story of how physicists are proving your experience of reality is a perceptual trick, and how quantum mechanics might finally explain why time feels the way it does.
Let's start with what you feel.
Time seems obvious, fundamental, unquestionable. You remember the past. It feels fixed, unchangeable. The data is stored in your neurons. You experience the present. It feels immediate, vivid. This is now. You anticipate the future. It feels open, unknown. Possibilities, not certainties. And there's a fundamental asymmetry. Your memory works backward, not forward. You can remember what you had for breakfast. You can't remember what you'll have for dinner tomorrow. This seems to prove time has a direction, an arrow, past to future. But what if this entire experience, this sense of time flowing from past through present to future, is just how your brain interprets a reality that's actually timeless? (1905). Albert Einstein publishes Special Relativity, and with it, he shatters time. Before Einstein, everyone assumed time was absolute, universal, a cosmic clock ticking the same everywhere. Newton's time, absolute, true, and mathematical time, of itself and from its own nature, flows equably without regard to anything external. Einstein proved, no, time is relative. It depends on your motion, on your frame of reference. Two events that are simultaneous for one observer can happen at different times for another observer moving at a different speed. Hermann Minkowski, Einstein's former teacher, took this further. He reformulated relativity not as three-dimensional space plus separate time, but as unified four-dimensional space-time. And from this came the block universe. In this picture, space and time are coordinates of one fabric. Past, present, and future are equally real. All events, everything that has ever happened or ever will happen, coexist in a four-dimensional geometric structure. Think of a film strip. Every frame exists, the entire movie is there. But when you watch it, you experience one frame at a time, creating the illusion of motion, of time flowing. Your life is like that. The entire path, your world line, exists. Birth to death, all of it, there, now. You just experience it sequentially. But there's a problem. Many physicists find this deeply uncomfortable. If the future already exists, what happens to free will, to choice, to possibility? Karl Popper argued against the block universe from a common-sense standpoint. John Lucas wrote, The block universe gives a deeply inadequate view of time. It fails to account for the passage of time, the preeminence of the present, the directedness of time, and the difference between the future and the past. And here's what's fascinating. As of 2025, there is no experimental data that definitively supports or refutes the block universe interpretation. It remains a philosophical concept rather than a scientifically proven theory. In September 2025, physicist Bill Giannakopoulos argued that the block universe is just one interpretation of relativity, not the only one, just as quantum mechanics admits multiple interpretations, many worlds, Copenhagen, etc. Relativity admits interpretations where becoming is real, not illusory. So, we have competing pictures. Presentism. Only the present exists. Past is gone. Future doesn't exist yet. Growing block. Past and present exist. Future doesn't. Reality grows as time passes. Eternalism. Block universe. Past, present, and future all exist equally. Relativity doesn't force us to choose eternalism, but it strongly suggests there's no universal now. If I'm moving relative to you, events that are simultaneous for me happen at different times for you. There's no objective fact about what's happening right now across the universe. So if time doesn't flow in relativity, what are we experiencing? To answer that, we need quantum mechanics. 1967. Physicists John Wheeler and Bryce DeWitt write down an equation for quantum gravity. It's called the Wheeler-DeWitt equation, and it has a shocking property. It contains no time variable. In quantum gravity, the wave function of the universe doesn't evolve in time. It just is. Static. Frozen. This created what's called the problem of time. If the universe is described by a timeless equation, where does time come from? Why do we experience it? 1983. Don Page and William Wootters propose a radical solution. They call it the Page-Wootters mechanism. The idea: time emerges from entanglement. Take two non-interacting but entangled quantum systems. One acts as a clock. The other is the system you're observing. Even though the overall state is timeless, satisfying the Wheeler-DeWitt equation, the system appears to evolve in time when you use the clock as a reference. Time is correlation. Time is entanglement between observer and observed. In 2021, researchers published work in Nature Communications showing there is not a quantum time, possibly opposed to a classical one. There is only one time, and it is a manifestation of entanglement. They proved you could derive both the Schrödinger equation and classical equations of motion from the Page-Wootters mechanism. In 2013, at the Istituto Nazionale di Ricerca Metrologica, INRIM, in Turin, Italy, researchers performed the first experimental test of Page and Wootters' ideas using photons, confirming that time is an emergent phenomenon for internal observers, but absent for external observers. Think about that. If you're inside a quantum system, entangled with a clock, you experience time. If you're outside, observing the whole system from some higher dimension, you'd see no time. Just correlations. Just a static, timeless quantum state. In September 2025, researchers published work showing quantum algorithms based on Page-Wootters can compute temporal properties over n different times using only log n clock qubits, achieving an exponential speedup by treating time itself as a quantum resource. Now apply this to you. You are a quantum system, roughly 7 times 10 to the 27th atoms, each one entangled with its environment, with light, with air molecules, with the rest of the universe. Your experience of time, your sense of now, emerges from those correlations. October 2024. Scientists at TU Wien measured the birth of quantum entanglement on attosecond timescales, billionths of a second. They found that entanglement doesn't happen instantaneously, but unfolds over extremely short times, around 232 attoseconds. As physicist Eva Brzezinova explained, the electron doesn't just jump out of the atom, it is a wave that spills out of the atom, so to speak, and that takes a certain amount of time. It is precisely during this phase that the entanglement occurs. Time doesn't just exist, it happens, it emerges, from quantum correlations building up, moment by moment. September 2024. At CERN's Large Hadron Collider, the ATLAS collaboration observed quantum entanglement at the highest energies yet, between top quarks, the heaviest fundamental particles, confirming that entanglement persists even at extreme energy scales. Physicist Regina de Manna's group confirmed for the first time that spin entanglement persists between unstable top quarks, at distances farther than what can be covered by information traveling at the speed of light. True, spooky action at a distance. Theorists believe the universe was in an entangled state after its initial fast expansion. Understanding how entanglement persists or breaks could help explain what led to the loss of quantum connection in our world, why time became classical. So if time emerges from entanglement, if the block universe is one consistent interpretation of relativity, if your experience of now is just you being entangled with your environment, what does this mean for you? Free will. If the block universe is real, and your future already exists in space-time, are your choices predetermined? This is the eternal debate: determinism versus free will. Some argue conquest measurement's non-reversible nature rules out the block universe. You can't reconstruct a quantum system's previous state after measurement. But the many worlds interpretation could preserve a block mega-universe, where all possible outcomes exist. In that view, every decision you make exists. All the paths taken, all the paths not taken, they're all there in the block. You just experience one thread. Here's a philosophical problem called Socrates' thought. Imagine Socrates in ancient Athens thinking about now. He thinks tenselessly that his thought is occurring on the edge of being. But from our perspective, he's in the past. How can you be sure you're not in the same position? That what you call now isn't already past from some higher perspective? You can't. What about déjà vu? That eerie feeling you've experienced this moment before. In a block universe, maybe you have. Not in a past life, but in the sense that this moment exists eternally. You're always experiencing it. You just don't usually remember experiencing it. But here's why we experience time as flowing in one direction. Thermodynamics. The second law. Entropy increases. Disorder grows. Eggs break. They don't unbreak. Smoke disperses. It doesn't gather. This gives time its arrow, not because the block doesn't exist, but because of how we're embedded in it. Philosopher Michael Tooley argued, effects depend on their causes in a way causes don't depend on effects. This asymmetry is only possible if effects aren't real at the time of their causes, suggesting a growing block where the present keeps adding to the past. Your consciousness might be like a spotlight moving through the block. The block exists, all of it, but you illuminate one moment at a time. And death? In a block universe, you don't cease to exist. Your world line simply ends at a particular point in space-time. But all the moments of your life, from birth to death, exist eternally in the block. You're always there, always experiencing every moment you've ever lived. It's strange, comforting and disturbing at once. Can we prove this experimentally? Maybe not. The block universe is an interpretation, not a prediction. Like quantum interpretations, many worlds, Copenhagen, etc., different views of time can make the same predictions. You can't experimentally distinguish between interpretations if they're empirically equivalent. But we can test specific mechanisms. Like Page-Wootters, like the emergence of time from entanglement. In 2024, physicist Joan Vaccaro published work in Philosophical Transactions of the Royal Society, arguing that dynamics itself may be a phenomenological consequence of fundamental time reversal symmetry violation, connecting quantum time to our subjective experience of progressing through time. In May 2025, researchers at the University of Alabama published a hypothesis where time's flow and quantum measurement are emergent features of traversing a fixed 4D space-time lattice, like a quantum movie reel, where the universe is created, complete at the Big Bang. Different models, different interpretations, but converging on a strange conclusion. Time might not be what you think it is. So what does this mean for you? Right now, you feel like you're in the present, reading this, thinking, experiencing. And that's real. Your experience is a consequence of your entanglement with the universe, with photons hitting your retina, with air molecules vibrating your eardrums, with neurons firing in patterns correlated with the world around you. You are a process, a pattern, a thread of correlations woven through space-time. And here's the beautiful paradox. Time is real enough for life, real enough for memory, real enough for meaning, but unreal enough for physics. Physicist Julian Barber argues in The End of Time that time is an illusion emerging from configurations of the universe. We think we remember the past, but really we're just in a present configuration that contains records. Physicist Lee Smolin counters in Time Reborn that time is physically fundamental, and laws of physics themselves evolve over time via cosmological natural selection. At the 2016 Time in Cosmology conference, physicist Avshalom Elitzer declared, "I'm sick and tired of this block universe. I don't think that next Thursday has the same footing as this Thursday. The future does not exist. It does not. Ontologically, it's not there." Elitzer and Shahar Dolev argue that quantum mechanical experiments, like quantum erasers and black hole evaporation, challenge the block universe and support an objective passage of time. The debate continues, and that's okay. Because whether time is ultimately real or emergent, you still experience it. You still make choices. You still love people. You still fear death. You still hope for tomorrow. In December 2024, scientists at Northwestern University successfully teleported quantum information across 18 miles of public fiber optic infrastructure using entanglement, bringing science fiction closer to reality. A 2012 experiment showed particles that never existed at the same time nevertheless exhibited correlations that violated classical statistics. Entanglement across time itself. The US is developing a national quantum internet, a secure backbone built on entanglement and quantum teleportation that could revolutionize computing, finance, and defense. We're learning to manipulate entanglement, to create it, to preserve it, to use it. We're learning to work with the very fabric that creates time. And maybe, eventually, we'll learn to see beyond our limited temporal perspective, to glimpse the block, to understand what it means that all of this, past, present, future, exists. Here's what we know. Relativity shows there's no universal now. Simultaneity is relative. Quantum mechanics suggests time emerges from entanglement, from correlations between systems. Experiments from 2024 and 2025 are measuring entanglement at attosecond scales, at the highest energies, across vast distances. The block universe is one interpretation, not proven, but consistent with everything we observe. So when someone asks, "What time is it?" the physicist's answer might be, "Time is the entanglement between you and your environment, manifesting as change in a fundamentally timeless quantum state embedded in a four-dimensional space-time structure." But the human answer is 7:42 p.m., and both are true. The experiments continue. In September 2025, researchers at DTU used entangled light to demonstrate a proven quantum advantage, learning a system in 15 minutes that would take classical methods 20 million years. In October 2025, physicists discovered that even classical gravity can generate entanglement when combined with quantum field theory, complicating tests for quantum gravity, but revealing new subtleties in how entanglement works. We're getting closer to understanding time's nature. Maybe we'll prove it emerges from quantum correlations. Maybe we'll discover something even stranger, that time is partly emergent, partly fundamental. Maybe we'll learn to manipulate it. Or maybe, like quantum mechanics itself, there are multiple consistent ways to interpret time. Presentism, only now exists. Growing block, past and present exist, future doesn't yet. Eternalism, everything exists, your experience of flow is emergent. They make the same predictions. They're empirically equivalent. The choice is philosophical, not scientific. But here's what changes. If time emerges from entanglement, then every moment you experience is a manifestation of your quantum connection to the universe. You are not separate from the cosmos. You are woven into its fabric. Your sense of now exists because you're entangled with photons from the sun, molecules in the air, atoms in your body. You are correlation made conscious. In the block universe interpretation, you exist eternally, not in heaven or an afterlife, but in the structure of space-time itself. Every moment you've lived, every joy, every sorrow, every choice exists forever in the block. You're not moving through time. Time is moving through you. And whether that's literally true or just a useful way to think about quantum correlations, it changes how you see this moment. Right now, whatever now means, is all you have, and all you've ever had, and in the block, all you'll ever need. This is Cosmic Canvas, where we explore the universe's deepest questions, from the nature of time itself to the quantum fabric that might create it. Until next time, pay attention to this moment. It might be more eternal than you think.